so in this part of the notes, I'm now going to get to our significance test. Before we can get to that, I just want to kind of put a little bit more vocabulary and name some more things. And so at this point, we're still partially in chapter 14, partially in chapter 15. They're kind of intertwined together. So anyway, we're just going to go through a few more vocab terms and then get into the actual computations for a significance test. Okay, so a few things. First, we can call things, or you'll see the wording is z-test statistic. Basically, the z-test statistics is really the same thing we've been calling the z-score. Now we're just using it to help us test for significance, so we can call it the z-test statistic. Okay, next thing, a p-value is just the probability we found in the following ways. So it's really the same thing as calculating the probability. So anyway, the little p-value, if you watched the intuitive examples video, is just that little probability of whatever tail ends, or sometimes you might have one, sometimes you might have the left tail, sometimes you might have the right tail, sometimes you might be looking at both tails. So when we're computing the p-values, there are a few different possibilities for when we calculate them. Okay, so we can have one case, and that's if we have our alternative hypothesis being greater than the mean, and for this, our p-value is really just going to be the little tail end. So this is going to be our mu, okay, and this is like our x bar value. Okay, our p-value would just be this tail end, so that probability we're looking at. Okay, and then I guess, oh, there's case one up here, sorry. Case one, we could have it less than, so if it's less than, what we're really looking at is this little guy, so x bar here, this is our mu, this little guy is our p-value. Okay, so it's really kind of the same thing we did in the intuitive examples, right? If it's not equal to, since you don't know if it's less than or greater than, we look at both tails. So the p-value, if we have something that's not equal, is just these two tails added together. So add two tails. Okay, so those little probabilities. Okay, so that's kind of what we're looking at here. So we use this if we're hypothesizing less than, this if I'm hypothesizing greater than, and then both tails will be our p-value or our probability if we're just assuming not equal to. Okay, a couple other things is, what small probability do we accept to be statistically significant? So remember in the first video we had like a little p-value of 0 here, and then we had one of, I think it was 0.0166, and I was like, oh, for the 0.0166, you know, it kind of depends. Well, now I want to put a specific p-value, so I want to say, all right, which p-value is small enough to say that we actually have statistical significance? Okay, so this can typically range anywhere from 1% to 5%, so that would be p equaling to 0.01 to p equaling to 0.05, but that part really just kind of depends on the researcher. But anyway, when we're looking at this, what we're really calling it is a significance level. Okay, so for a significance level, we usually call it alpha. It's the decisive value of p. So if the p-value is as small or smaller than our significance level, then we say that the data are statistically significant. Okay, so basically, if the p-value, if we calculate this little probability, and it's less than alpha, we'll reject the null hypothesis and accept the alternative. If we compute that little p-value that's greater than alpha, whatever we choose our significance level to be, then we're going to accept the null hypothesis because there isn't enough evidence against it. So this would be, we're accepting the null hypothesis because our sample is so close to that, based on our p-value, that there really isn't enough evidence to conclude that it wouldn't be accurate. Okay, so now that we have the vocab, I'll actually go through and start working on some of the computations.